How wonderful that we have met with the paradox. Now we have some hope of making progress. Quoted Niels Bohr. To unsolve a mystery, a theory is needed. To know more about the nucleus and its internal structure, a nuclear model is required. There are a lot of nuclear models exist today to explain an atomic nucleus and its internal structure. But the first and the most popular model, which paved the way for many modern theories about the nucleus, is liquid drop model. In this video, let us discuss about the liquid drop model of a nucleus. Liquid drop model was actually proposed by George Gamow in 1927, but it was later developed by Niels Bohr and J. A. Wheeler in 1936 to explain the process of nuclear fission. Why this model is superior than other nuclear models? Because this model was able to provide satisfactory explanation for many nuclear phenomena which other nuclear models could not account for. Okay, so what are the basic assumptions assumed by Bohr and Wheeler for this model? They assumed that nucleus is spherical in stable state. Secondly, we know nucleus is made up of a proton and neutron, and these proton and neutrons are incompressible. And the nuclear forces, the strongest forces in the nature that exist between the nucleons, is identical for all the combinations of protons and neutrons. This is the third assumption. And the fourth assumption is the nuclear forces saturates. So these are the assumptions made by Bohr and Wheeler for explaining their liquid drop model. Now let us look at the similarities of the properties between a liquid drop and the nucleus. Okay, first let us discuss the property of density. The density of the nucleus is independent of its size. So though the nuclear may look big or the small, the density is same for all nucleons or all nucleus. Hence, the density of the nucleus is independent of its size. Similarly, for a liquid drop also, the density is independent of its size. Be it a bigger drop or a smaller drop, the density is same for a liquid drop. The next property is, we can see for a liquid drop, it has a latent heat of vaporization. It has a constant. This corresponds to, or this is an analogy to the constancy of binding energy per nucleon. This binding energy per nucleon attributes to the stability of the nucleus. This is in analogy to the latent heat vaporization of a liquid drop. The next similarity is the nucleons inside the nucleus moves over a very small distance inside the nucleus. This is an analogy to, or this is similar to, the molecules of the liquid drop also moves to a very smaller distance inside the liquid. So this is also similar. This is also a similarity between the liquid drop and the nucleus. The next similarity is their shape. We know a liquid drop is spherical. This is because they have a surface tension property, the inherent property of a liquid. In the same way, a nucleus is a spherical in shape. So both are similar in terms of the shape. Next, in terms of forces, the next property is forces. We all know the nuclear forces, the strongest force in nature are short range forces. Similarly, the molecular forces that exist between the liquid drop is also a short range force. So the liquid drop and nuclear, the forces between the liquid drop and the nucleus is also a short range one. The next is sphere of influence. The influence it can uh, put it over its neighbor. See, both the molecules in the drop and the nucleons in the nucleus can interact only with the small number of their closest neighbors. So, the molecules in the drop interacts only with the by molecular theory. We have already seen in the properties of matter, it can interact only with the closest molecules. Similarly, the nucleons inside the nucleus also interact with the nearest nucleons. Okay. So next property is, let us give some energy to a liquid drop. So when a molecule of the when a molecule of the drop is given some energy, it starts leaving the liquid drop due to the process of evaporation. Or when a temperature is raised, the liquid drop leaves the molecules leaves the liquid drop by gaining energy in this process. Similarly, when you give some energy to a nucleus, or the nucleons in the nucleus, they gain energy and it leaves the nucleus. This okay. So this is also a similarity between a liquid drop and the nucleus. And the energy of the nucleus is an analogy, or it corresponds to the internal thermal vibration of a liquid drop molecules. So as a nucleus have some energy, in the same way the liquid drop also have internal thermal vibrations. This is one important phenomenon which this liquid drop model was able to explain successfully. When a liquid drop is allowed to oscillate, when you give an external force or vibrate a liquid drop, it breaks up into two or more smaller drops of equal size. Similarly, when you hit a nucleus with a neutron or give some energy from outside, the larger nuclei breaks up into two or more smaller fragments. This process is nothing but the process of nuclear fission. So by this way, Bohr and Wheeler were able to explain nuclear fission. See, if you have many drops, many small drops, these drops condense together to form a large drop. In the same way, a nucleus can also form a compound nucleus, and by absorbing the bombarding particles. This process is nothing but the process of nuclear fusion. That is, two or smaller lighter nuclei combine to form a larger nucleus. This process this process of condensation of drop is attributed to the nuclear fusion process. We know on the surface of a liquid drop, the surface tension forces exist. Because of this, the surface of a liquid drop behave as a stretched membrane. Similarly, there will be a potential barrier in the surface of the nucleus. So there are lots of similarities between the liquid drop and the structure of the nucleus and the liquid drop. Thus, this model was called as liquid drop model. Next, what are the merits and demerits of this model? This liquid drop model was more popular because it explained the spherical shape of the nucleus, and it explained the stability of the nucleus, and the most successful one is the explanation about the nuclear fission, and it was successfully able to explain the radioactivity emanating from the heavier nucleus, and it was able to explain the properties of alpha and beta emissions. Though it was able to give a satisfactory results, there are a lot of demerits and limitation to this model because it is a crude model and it was not able to explain the stability and the binding energy of especially even numbered nucleons. The even numbered nucleons have more stability than the even odd, I mean odd, even odd nucleons. And we all know about the magic numbers. The magic numbered nuclei have more stability. Why these numbered nucleons are more stable was not explained by liquid drop model. The magnetic moment, the spin of the nucleons, and the energy levels existing are not explained by the liquid drop model. The limitations of this model led to a new model called a shell model.